2, and from what your roadmap was, can we have Richard Iranya? I don't know whether Richard is with us. Richard, if you're there, may we see by show of hands, by putting up your hand, Richard Iranya. Most likely we don't have Richard. If Richard is not there, do we have Namatiti Siraj? Siraj? I see Namatiti Husna. Could you be the one? Mr. John, Mr. Bakayana, may you please, thank you very much. Okay, Husna, please go on with paper 2.
Thank you so much. Good morning, everyone. Good morning, teacher. I'm not fine health-wise, so I'm going to present one number, which was from the part of algebra, complex numbers in particular. I don't know if I'm going to...
Husna, did you have a paper 2 question?
Complex numbers.
That is paper 1.
Yeah, it's paper 1, sorry.
Okay. As Husna goes ahead, please let us have Ambrose Watumu preparing, because we want to hear from someone giving us paper 2. Okay, Husna, go ahead.
I think I'm going to present through video. Is it okay? Because I'm not well versed with the screen sharing.
Please go ahead.
Okay. So I don't know if you can see very well. The question says, given that z is 2 minus I is a root of the equation z cubed minus 3z squared plus z plus k equals 0 is real. K is real, in other words. So find the other roots. It was question 10 on the part of algebra from the questions in the same math seminar. The questions you were given. I wanted that one. Don't worry. Okay, so I started out with, please first give me a minute.
Usuna.
Yes.
Request those siblings to give you just 10 minutes. Then they will come back.
I'm sorry, let me work on that.
It's okay. We are patient about it.
Mr. Bakayana, I think Emmanuel Wataka wants co-host rights.
Can I say something?
Yes, please, go ahead.
Me, Husina should take pics like somebody is advising. She should take guide her on what to do when pics are in the phone already. Who wants to present next?
James, did you also have something to say, James Echangoit? James, please open your mic and say something, James. Alan Magezi?
Hello. Hello.
Yes, James, we can hear you.
Yeah, I'm called.
James, you muted again.
Okay. I'm saying I'm James Echangwait, a teacher of mathematics and physics. I teach mathematics paper 2 at Viva College. Yeah, so what I'm trying to say, maybe after the other one, we can go to paper 2 and I can guide.
Thank you very much, James.
Welcome. Otherwise, nice.
Mr. Bakayana, may you please make James a co-host? Priska? Priska? Okay, we lost Priska. I was waiting to see what we have from Husna, but if then could we have Ambrose Watum? Ambrose, please,
Yes.
can we, as we wait, can you please take them to the field?
Good morning, everyone.
Good
My name is
morning.
Watum Ambrose from St. Andrews College, Tovu. So I'm taking you through paper 2. That is part of probability. Number 15. So you wait as on screen.
I have shared the solutions to the teacher, so hopefully you'll find them in the group. Thank you.
I'm sharing. You can see my screen.
Ambrose, you are not yet sharing. You are not yet sharing? Ambrose?
Seeing my screen. Hello, teacher.
Yes, we can see your screen. Can you try to magnify a little bit?
Number 15.
Okay.
In a farm, 35% the cows infected.
Ambrose, can you make it a landscape? Is it possible to rotate your phone and have screen rotation and then you rotate your phone? Meanwhile, Teacher Emma has given
It is not possible.
Okay, go ahead. Teacher Emma has just given us a link to join the groups. Thank you, Teacher Emma.
In a farm, 35% of the cows are infected by a tick disease. If a random sample of 400 cows is selected from the farm, find the probability that less than 30% of the cows are infected. So this is part of probability, but the way I interpret it, it is kind of binomial distribution. But in probability, if the number of trials n is greater than 20, So it will be now normal approximation to binomial. So in my solution, you can see n is equal to 400. So I'm saying x, I've not written this one, but we're supposed to say, let x represent a random variable for the number of cows. So x will follow a binomial distribution with 400 trials and the probability of success being 0.35. I got this 0.35 from my percentage, the one they said 35%. So it will be 35 divided by 100. So that's the probability of success. In the same way, n will follow a normal distribution with mean NP and variance NPQ, where P is the probability of success, Q is the probability of failure, then N is the number of trials. So after that, I get my X following a normal distribution with mean 140 and variance 91. So they're saying, find the probability that less than 30% of the cows are infected. So 30% of the cows, it means 30 out of 100 times the total. So it will be 120 cows. They're saying probability of X less than 120. But this one is normal approximation to binomial. So we approximate. When we are approximating, if it is less than 120, on the other side, we subtract 0.5. That is why I approximated to be probability of X less than 119.5. So if probability of X is less than 190.5, I standardize. You remember that in normal distribution. So in standardizing will be probability of Z less than 119.5 minus the mean, which is 140, divided by standard deviation, the square root of variance. So I get probability of Z less than negative 2.149. So that one now, I go and locate it on my normal curve. On the normal curve, those are problems in plotting, in indicating this in a normal curve. So in this normal curve, the Z value is a negative. So I indicate on the negative side. This is the negative side. Then they're saying it is less. So I said the other side of less. So the probability of Z less than negative 2.149 will be now equal to 0.5 minus probability of 0 less than Z less than 2.1490. That one, in the other part where 0 is less than Z is less than 2.1490, may I use the table. And after using the table, I got that answer, and this is my answer. So we go to the next part, part B, the probability of more than 155 cows are infected. So probability of more than 155 cows are infected, I approximate again. I do continuity correction. So it will be probability of X greater than 150.5. I add there 0.5. So I standardize. Will be 150.5 minus 140 divided by the standard deviation, which is the square root of variance. So I get my Z greater than 1.10. Now I go to my normal curve. In my normal curve, since the Z value is a positive, I locate it on the positive side. Now I come to determine the sign, it is greater. So I say the other side of greater. Now we are getting the probability. The probability will be 0.5 minus probability of 0 less 0.5 minus 0.3645. Me, I use the table, and that one is my answer. So we're going to part B. They're saying the probability of number of cows between 120 and 155, inclusive. So if it is inclusive, it means you have to say less or equal to or greater or equal to. So it is 120 less or equal to X, less or equal to 150. Now I do continuity correction. It will be probability of, since this one is less or equal to, but I can see that my X is like greater or equal to 120. As it is greater or equal to 120, I have to subtract 0.5. And I get my answer 119.5. Less or equal to X, less or equal to 150.5. That side after adding 0.5. Now I standardize. Will be 119.5 minus 140 divided by the variance. Those are my answers down. I go to the normal curve. Since it is a range and we have a negative and a positive, I indicate that on my normal curve. Then I set the region in between the two. Now the probability will be the probability of 0 less than Z less than 2.149 plus probability of 0 less than Z less than 1.101. So from the table, I will get that answer. That's the end. Thank you very much.
All right. Thank you, Ambrose, for that presentation. Keep your work on the screen. Yes, Priska. Priska, can you ask?
Teacher, I wanted to ask, which topic is this? Is this binomial or normal distribution?
This is normal distribution. The chapter is normal distribution, but it has been interlinked to binomial distribution. We have a subsection we refer to as normal approximation to a binomial distribution. That's the chapter we are doing. Right, can I hear from Amza Samuel? Please unmute.
Yes, sir. I'm just asking, like, this topic is a bit complicated. Like, it was not clear. Maybe you give us some elaborate on it, on how we can understand it better. That is it.
It is okay, but Samuel, have you covered normal distribution at your school? Samuel, have you covered this?
Just wrote the heading, but did not cover it.
Yes. Yeah. In a seminar like this, I want to throw light here. In a seminar like this, where we are still in the first term, some of us are ahead of the others, but we have come to share. So have an open mind. When you say something you've not yet learned, you don't. I've liked the way Samuel has asked. Yeah, but some people in the chat seem to be looking at it for the first time, and they were not responding well. Just be open-minded. You can actually learn it starting from now. So it's okay. Maybe for being on record, let me know Ambrose's station. Ambrose, which school are you attached to? As you...
Teacher, I'm from College Tovu.
St. Henry's College, Tovu. Thank you. Trishila, can you also ask, as any one of my colleagues prepares to say something as well? Please unmute. Trishila. Yes.
Excuse me, teacher. I'm asking, like, after this part of standardizing, like dividing, like, 119.5 minus 140 out of like the square root of 91. So when we are dividing that, to how many decimal places should we write the answer so that we read it off from like that table?
Standard number of decimal places to which you are expected to write the Z value is 3 decimal places. It is 3 decimal places. Take note. It is supposed to be 3 decimal places. Okay, Tekino F1 11. For you, you didn't rename. Can we hear from you? Yes, Levin. Is not unmuting. That is unfortunate. Let me hope. Yes, your mic is on.
No,
Levin.
thank you, sir, but hello.
Yes, please.
What I wanted to ask is that for us, they told us that if you get a negative when you're drawing this normal distribution diagram, that
table.
If you get a negative answer, is this side of the gundi. Since this line of the symmetry, you bring it this side because the table can't reach the negative.
Yeah, it is okay as long as what he has been doing is also fine. That is a symmetry property you're mentioning, Levin. It's a symmetry property. So whether you show it or you don't, as long as you go to the table, you read for us the correct Z value. So if this is your curve, if this happens to be your curve, and you have the Z value this way, it's negative. The area it represents, the area it leaves to the left is the same area it would leave if it was put this on the positive end. Symmetry. It's a symmetrical curve. So drawing your curve and you're reading the probability of Z less than negative 2.149, and you want this probability below it. It's actually similar to the other area. It's similar to 2.149 positive, and you read for us that one. So the tables read this. The tables can generate for us that one that is positive. That's why we are comfortable with someone who draws this diagram and it transfers and draws this again. But for time consumption or time interest, as long as you draw this diagram, but you go to the tables and you read this Z value, it's okay. It's a concept everyone must know, that it's a symmetrical curve. The normal distribution curve is a symmetrical curve. Then about continuity correction, I don't know whether any one of my colleagues had interest in mentioning about it. But anyway, about continuity correction, when we have the probability of Z greater than 2, remember originally it was a binomial distribution which is discrete in nature. Greater than 2 in a countable domain or discrete data implies you're beginning at a value above 2. 2 is not inclusive. However, if I wrote it as Z, let me not use Z for clarity, let it be X greater than, say, 20. is different under binomial or discrete data. It's different from greater or equal to 20. If we were listing 20, 21, 22, 23, and so on, greater than 20, if you are listing that set, you would begin at 21, but greater or equal to 20, 20 would be inclusive as you move forward. So that's what you have to put into consideration as you do continuity correction. So this is discrete. As I correct it to become continuous, I put into consideration the fact that the figure 20 is not inclusive. So this is my 20. Since it's not inclusive, I begin at a value above it. And each value to consider is away from 20 by 0.5. So behind 20, we have 19.5. Above 20, we have 20.5. If 20 is not inclusive, as you go in the increasing direction, that means you will start here. So this continuity corrected becomes greater or equal to, or just greater than 20.5. This one is discrete. This statement is continuous. So when you correct this one, when 20 is inclusive, if 20 is inclusive, then as you do a continuity correction, you will go slightly behind it by a magnitude of 0.5. This will be greater or equal to 19.5. And it can be a jointed statement where you have, say, x is greater than 19, but less or equal to, say, 30. This is discrete. I want to write the same range as a continuous one after doing a continuity correction. So if this is to become continuous, what would happen? I always tell candidates to read this individually. Read off x less or equal to 30. So come this side and say this is x. It's going to be less or equal to 30 implies you have 30. Above it, you have 30.5. Below 30, you have a 29.5. You want to move below. You are going downwards. Less or equal to from 30 and below, but 30 is inclusive. So I start at 30.5, such that as I go downwards, I capture the 30. I don't know whether I'm communicating to somebody in this audience. X, then the other counterpart is now x greater or equal to 19. Actually, not equal to. There is no equal sign. If I remove my green, it's x greater than 19. That means if I have my 19, above it is 19.5, below it is an 18.5. But x greater than 19 implies the 19, there is no equal sign. 19 is not inclusive. As I move above, I will take 19.5. So this will be 19.5. 19 is not inclusive. I'm ready to do any highlight if my colleagues would wish to add on beyond this point. Okay, Julia, Emma, you can ask before we proceed. Julia, your network as Julia, can you please type in the chat? Our network has failed us. Trishila?
Teacher, I have not understood the part where you have said that if x is less than or equal to 30. I thought we would begin from 30. Why are we adding on 30.5?
Okay. That is one clear question. Julie, have you looked at normal distribution? Oh, a mic, she has gone off. Okay. Julie has also asked the same thing. Why is it 30 with Tricia? Why is it 30.5? So less or equal to 30 is discrete. This statement is discrete. To be continuous, to shift from a discrete, maybe to mention, to shift from a discrete statement to a continuous one, you must add or subtract 0.5 on the given statement for it to become continuous. That is if you're dealing with a normal approximation to binomial statement, which only happens if the number of trials given is greater than 20. You have a probability of success. So after you following a binomial distribution for your N and P, you now follow a normal distribution in which you will have these parameters. So the intervals that you will handle using a normal distribution must have been accumulated or be reduced by 0.5. Those of binomial are the ones you reduce and add 0.5 to them. By that interpretation, I've been elaborating for you to shift into a normal distribution. So someone is saying, what about the one of less than 30 just? What if it was just less than 30? What about if the interval was just less than 30? I shouldn't even mention a probability. If it was just less than 30, this is discrete. And this side we want to mention it as continuous. In a countable domain, less than 30 would mean you would start, you're going downwards and you will go up to 0 in a discrete, but you are at 30 and it's less than 30. Actually, in a number line, if you people remember, less than 30, you would draw it like this with an open circle, meaning 30 in that domain is not inclusive. One would go below, starting at which value in a countable domain with integers. Can you feel the chart? As you go in the decreasing order, less than 30 would push you to start at what? Can you tell us in the chat? In a countable domain, before you will correct continuity. Some people have already corrected continuity. In a discrete order, less than 30 would imply the vote goes to those that are mentioning 29 in a countable domain, because you will not count a decimal. Listen to that statement. The discrete pattern or a binomial distribution is following a countable domain, discrete, binomial. So this means this is 29 and followed by 28. If you were mentioning the individual terms, 27, 26, till none, which is 0. So in a continuous, if this is 29, as we correct continuity, we can shift to 29.5 or below it, which is 28.5. But as we go below, we are saying 30 is not inclusive. So it's 30, it's supposed to be 30. Our point of reference is 30. It's a 30. Above it, we have 30.5, and below it, we have 29.5. So as I move in this direction to the left, as you go to the left, leave the 30, don't capture the 30. So in continuity correction, 0.5 below 30 puts us at 29.5. That means under continuous, this range will become X less than 29.5. Remember, by the way, if you are away under continuous, whether with an equal sign or not, it is a continuous range, meaning it begins at 29.5, whether with the equal sign or not under continuous. But under discrete, it has an effect. I've spent some minutes for some presenter that would have followed. I've taken some minutes there. I beg to submit. Over to you, teacher Kajim.
Thank you very much, Teacher Lawrence, for that guidance to us. May I request to know if there's someone with the mechanics? Because these ones who are having paper 2, yes, I can't tell exactly which questions you are going to try. Is there anybody with the mechanics? Patrick and Ruth Cherotich, is there any mechanics in what you are trying, what you are supposed to try? Do we have Patrick? Wawuya and Ruth Cherotich? Can we have someone with mechanics? Teacher Lawrence, am I clear?
Yes, sir. You're loud and clear.
Okay, thank you. Dear participants, can we have someone with sharing with us a mechanics question? May I see those who are ready to present, those who have not yet presented? Makalas, what do you have?
I have a question, but it's from paper 1 analysis.
Okay, paper 1 analysis. Any other who has not yet presented? Yes, Ruth, you are from paper 2. We have been looking for you. Mr. Bakayana, may you please make Ruth a co-host? Ruth, which number is it? Where is it? Which part is it from? Numerical methods. That is Eric Tamari. Ruth, which part?
Teacher, I'd opted for paper 1, not paper 2.
For paper 1, not paper 2.
I think they made a mistake.
Is there anyone doing mechanics? Before I give all of you the chance, can I have mechanics, please? We don't have anyone completely?
Teacher Henry, can we give, has Eric presented?
Eric? Not yet. We don't have Eric.
So in place of mechanics, we can take that numerical methods number since we have not had any.
Okay.
From Eric Tamari.
Okay. Meanwhile, as Eric presents, if I could get someone go through a mechanics question and so that by the time is done, we can get something from mechanics.
And each section Eric would have had at least a number.
Okay. Okay, Eric.
Thank you, sir.
Thank you very much, Teacher Lawrence, for that guidance. Eric, Eric, put up your hand to have do you have the co-host rights, Eric? Mr. Bakayana, Eric doesn't have the co-host rights. Thank you very much. Eric, you're on floor. Please go ahead.
So good afternoon to all of the people here. Mainly for me, I'm going to share a picture such that we can simply go through the number that I'm having, and it is about index numbers. So let me think people are seeing my screen.
Yes, we can see your screen.
Okay, that is number 5 from numerical numbers, and this is now from price index. So the question is saying that in 2021, a bar of soap costed Uganda shillings 4,000, and in 2022, the same bar of soap is now costing Uganda shillings 80,000. Taking 2021 as the base year, they want us to find the price relative that is in 2022. So from the formula of getting the price relative, we get the price in the current year over the price in the old year times 100%. So as we check, the current year in this case is 2022 being a current, and 2021 becoming the base year. So 2020 becomes the base year, whereas 2021 becomes the current year. So you get the price in the current year, which is 2022, that is 8,000, over the price in the base year, which is 4,000 times 100. And for that case, that is how we are able to get 200. When you get 200, that is now the price relative, meaning that the price of the bar of soap now increased by 100%. And that is evident because if you are to check into the year 2021, if it was costing 4,000, in 2022 it was costing 8,000. That shows that it increased by 100%. That is 200 minus 100. Am I clear there? Members, am I clear?
Yes, you are clear. You are clear, Tamale.
Okay. Then part B of that same question. Part B of that same question was saying that the price index of an article in 2018 based on 2014 was 130. Then the price index of the same article in 2021 based on 2018 was 80. They want us to calculate the price index of the article in 2021 based on 2014. So as I said, the formula for finding the price index goes by saying that the price in the current year over the price in the base year times 100%. That's what I said as we are beginning. So we get the price now of 2018 over the price of 2014. And they are saying we are multiplying that with 100%. But if you're checking the question, they are saying that the price index of the article in 2018 based on 2014 was 130. That means that our price relative is 130, but the price relative of 2018 based on 2014. So you can make a price relative of 2018 over the price of 2014, the subject, by simply dividing 130 by 100, and you end up getting, I think, a 1.3. So the price of 2018 over the price of 2014 is giving us 1.3, and that one becomes our equation 1. Then they are saying that the price index of the article in 2021 based on 2018 was 80. Again, we can get the price relative by saying 2021 over 2018. Remember, I said the current year over the price in the base year. But now when you have to check here, if they say based on 2018, that means that 2018 is our base year there. So what is the price relative? The price relative, according to the question, was 80. So 80 equals to the price in 2021 over the price in 2018 times 100. And through there, we can also make the price of 2021 over price of 2018 the subject by simply dividing by 100 on both sides. That means that our price relative of 2021 and 2018 is 0.8. That shows that we have in equation 1 and equation 2. But as you check, the question wants us to get the price index of the year 2021 based on 2014. But here we have 2018 based on 2014. And we are also having 2021 based on 2018. So for me, I usually use the other method like the chain rule. So we have the price of 2018 over the price of 2014 times the price of 2021 over the price of 2018. And that one means I will also have to multiply those two prices as 1.3. I also multiply it with 0.8. According from the other two equations I got, yes, more colors.
No, it's okay. I just wanted. You can keep going. It's okay.
Okay, now from there we are getting the price of 2021 over the price of 2014. Since we are seeing that the price in 2018 and 18 are moving out, so we remain with 2021 over 2014, and that is what they want us to get. But they are telling us to get the price index, so we are getting it as 1.04. But you remember, as I got these values here, they were simply after dividing them by 100. So I have to multiply this by 100 to get the price relative. And therefore our price relative becomes 104%. Or somebody else is supposed to go ahead and makes one of these two the subjects and fixes it in one of the two equations. Again, you can end up getting the same price of 2021 over the price of 2014 as 1.04%. After getting that one, they are telling us that we get the price of the article in 2014 if the price of the article was 45,000 in 2021. So after getting the price relative here, as we have got it as 104%, as 104, I think the percent is not supposed to be there. So that one simply shows that the price in 2021, they're telling us it is 45,000 over the P note, whereby P note is now giving us the price in 2014, which we do not know as per now. So we multiply that by 100, but we have already got the price relative as 104. You make P note the subject, that is by simply multiplying the 45,000 by 100, then you divide your answer by 104. So you end up getting 4326.926, and that one is giving us the cost of the article, and that is the price. Once I think I'm done.
Thank you very much, Eric. And I saw Priska's hand up for some time. Priska. Trishila.
Yeah, on part of this question, after him finding the price index that was 200, why did he again conclude that therefore the price index increased by 100%? Because like they didn't ask for if it had increased or something of that sort, but why did he add on that statement? Is it supposed to be there?
Eric, did you get Trishla?
Yes, she's saying that why did I have to add on the other statement that therefore the price of the bar increased by 100%?
Yes, can you guide her?
according to me, Master, I see that we're having that the price relative, we have got it as 200. But they want us to give that relative that when you are to check this 200 is something which is greater than 100%, and it is greater by 100. That shows that this bar of soap increased by 100%. If it was at 4,000, meaning again they added another 4,000 onto the original 4,000 to make it 80,000. That is why I was able to put on that statement.
Okay, thank you. Mr. Bakayana, can you guide us here? As he comes around along. Jonathan, what is your issue? Jonathan? Okay, I can't get Jonathan. Mr. Bakaina, would you like to throw more light on this? Okay. Thank you, Eric. Thank you very much.
Welcome, Master.
For that presentation. Is there anybody who has picked on a mechanics number? Okay, Mukalas wants to be made co-host. Mukalas is requesting to be made co-host. Kitty? Brian, Kitty? Brian, you can unmute now.
Teacher, I have done the mechanics number.
Okay, which question is that? Can you guide us through so that we have a chance to also go through the mechanics? Thank you very much. Maybe before that, may I hear from Beno also? Mr. Bakayana, please help us give Brian co-host powers, also Mukalas. Beno, as these ones organized, Beno?
Yes, teacher.
I see your hand up.
I would like to present for mechanics.
Okay, you are going to be made a co-host. Can we go with Brian Kitty?
Okay.
You're going to be made a co-host, don't worry.
Let me get the question. I did question 34 and hope you can see it clearly.
Yes, it is very clear. Go ahead.
So it read 2 particles of mass 6 kilograms and 3 kilograms are connected by a light inelastic string passing over a smooth fixed pulley. Find acceleration of the particles, the tension in the string, and force acting on the pulley. Yeah, so it's a mechanics question, and our first step is usually to draw a force diagram if it's required. Yeah, so they said those 2 particles, one weighing 6 kilograms and the other weighing 3 kilograms, are connected by that string over a smooth fixed pulley. Yeah, so I drew my vector diagram as you can see it. Yeah, that's the string and it's connected to the 6 kilogram mass and 3 kilogram mass. Yeah, so we must show the forces acting on our diagram. Yeah, so there is a tension. Yeah, so we have this tension here. acting on that 3 kilogram particle, and the tension acting on the 6 kilogram particle. And similarly, we have a tension acting on the pulley. Yeah, as I indicated it here, on that side and this side. Yeah, so that's our diagram. Yeah, so I moved on to the working. Okay, yeah, we must understand the directions that the particles will be moving in. Yeah, so for the 6 kilogram mass, we know that it's heavier than the 3 kilogram mass, which means that the 6 kilogram mass will move downwards and the 3 kilogram mass will move upwards. Yeah, so next we'll be working out the question. Yeah, so for, remember vector has a direction. Okay, yeah, moving on to the calculations. Yeah, so for the 6 kilogram mass, I hope you guys can still hear me. Yeah, since it's moving downwards, it means that the next force, the resultant force is acting downwards. So a 6 kilogram mass is heavier than the tension. So we'll have 6 times the acceleration due to gravity, which is G, minus the tension T being equal to 6 times the acceleration. Yeah, that comes from the equation. Resultant force is equal to mass times acceleration. So in this case, the resultant force on the 6 kilogram mass is acting downwards. Yeah, so that's my first equation for the 6 kilogram mass. Then moving on to the 3 kilogram mass, remember the system is moving downwards on the side of the 6 kilogram mass. So since the 3 kilogram mass will move upwards, it means that the magnitude of the tension is heavier than the force that's generated by the 3 kilogram mass. So the resultant force on the 3 kilogram mass will be upwards, as I indicated by that arrow. So we'll have T minus 3G as a resultant force being equal to 3A. Still from force is equal to mass times acceleration. Resultant force is equal to mass times acceleration. Yeah, so next we'll be solving those two equations simultaneously to find the value of A and T. Yeah, so we can use any method we are free with, but I chose to use elimination, whereby if I add equation 1 and equation 2, I can eliminate T. Yeah, so equation 1 plus equation 2 gives me 3G being equal to 9A. Yeah, but we know that the value of G is 9.8 for this particular paper, math paper 2, 9.8. So we shall substitute 9.8 for G. So we have 9A being equal to 3 times 9.8. And when I solve that, I get the value of A as 3.2667 meters per square second as my acceleration. Yeah, then part B wanted us to find the tension, and that, okay, since we have the value of A, it means we can find the value of T, the tension. Yeah, so I substituted that value of A, 3.2667, in equation 2, and I had my value of T as 39.2001 newtons. Yeah, then part C wanted us to find the force acting on the pulley. Yeah, so as we see, our pulley is fixed, but we have two forces, T acting on it, T on the string on either side. We have T and T. Yeah, but since it's not, it's not moving, it means that there is a force that's helping that pulley to stay in what? In a single, to stay without moving, to stay static. Yeah, so I called that force R. And if that pulley is not moving, or if it's in one place, it means that R must be equal to the sum of the two tensions, T plus T. So I found R from 2 times T, which was 2 times 39.2001, and my R was 78.4002 newtons. And that was the entire question. Thank you.
Thank you, Brian. I see a hand up. Please take take the questions that we have here.
Some questions, guys.
Trishila. Oh, can you unmute now?
Teacher, I was asking, like for part C, if they ask the force acting on the pulley, is it the same question as the force acting away from the pulley?
The force acting on the pulley and the force acting away from the pulley. Brian, do you have anything to say about that?
Teacher, I think it's the same question. The force acting on the pulley or the thrust on the pulley. I think it's the same question.
Oh, she said thrust. That is the same. That is the same. Okay. Any other?
Teacher, I would like to request to be made a co-host.
Okay, Priska. That is Mukala's. All the time you have been asking to be made a co-host. I think they have been making you co-host. I don't know.
Yes, but my network keeps dropping me. Yeah.
Okay. Priska.
Teacher, I wanted to ask if you could please repeat part C.
Part C.
Yes.
There he is, still sharing. Ryan?
Yes, teacher.
Oh, did you hear Priska? Part C.
Yeah, okay. For that case, I applied is it the third equation of Newton's? Yeah, that equation for every, reaction, there is an equal and opposite force, something like that. Yeah, so the force acting downwards on that pulley is 2T, but that pulley is just in one place, which means there must be a force acting, the resultant force on it, R, will be equal to the sum of those two tensions, T plus T, which gives us 2T. Yeah, that's what I did. To give me 2 times 39.2001 and 78.4002 was my answer. Yeah, then someone asked whether this formula works for all cases. I think it doesn't work for all cases because there are some cases where the pulley is maybe at, it's like a smooth inclined plane and the pulley is maybe at the end of the inclined plane, like at the top of the surface. Yeah, so for that case, you can use the parallelogram law of forces to come up with a vector diagram and find the reaction on the pulley. I don't know whether I can. Let me try drawing it here.
But I also think, maybe the other issue that you could talk about, in this very case, if the pulley is heavy, if the pulley is not light, I think we should be having another force on the pulley. Ryan?
Yes, teacher.
Did you get me there? Okay, Mr. Bakayana has opened the mic. Mr. Bakayana, do you want to say something? Guidance?
Yes. Thank you so much, guys, for the presentation. Someone wants to take us through what happens with the reaction when we don't have that kind of arrangement. I would propose that there are very many cases that are around this subtopic, dealing with the pulleys and dealing with pulleys reactions. I would propose that we shall have different questions to capture the different arrangements that come up with such questions. For this one, where we have the two tensions acting vertically downwards, and then we have the reaction that acts vertically upwards, we use Newton's third law of motion. He called it Newton's equation, but it's supposed to be Newton's third law of motion, that the downward forces, the two tensions, are being counterbalanced by the upward force, which is the reaction. The other issue I want to correct is that sometimes someone said that, is it supposed to be the upward force or the force acting away from the pulley? I think when you say force acting away from the pulley, it doesn't bring out the concept very well. It's either the upward force for this particular arrangement or the reaction due to the pulley for this particular arrangement. For other cases, I think we shall have questions that bring it out very well. I don't think that it might be proper for him to bring out another concept that supposing it is like this, we shall end up having very many scenarios, very many situations that requires different arrangements of getting the normal reaction or the reaction due to the pulley.
Thank you very much, Mr. Bakayana, for that guidance. That answers the question by, is it Grace? I think it is Grace, where you are talking about circumstances where accelerations are different. That answers you that we have different, there are very many different cases that we could come up with. So we shall have questions that can discuss them. Otherwise, we may not be able to exhaust them right now without the proper guidance of those questions. Thank you. Thank you very much for that guidance. There was someone else who wanted to discuss another mechanics question. Beno?
Yes.
Beno, you are good to go. Mr. Bakayana still has something to guide us with. Yes, Mr. Bakayana?
Yes, still there is something that you talked about that is very important. Such questions, there's a situation where the pulley is not light. When it is light, then we assume that its weight is 0. However, if it has some mass, then it's a different case. I think we shall also have it included in another question that we shall give next time. Thank you.
Okay, thank you very much. Now, Beno, please go ahead.
So I hope everyone is seeing my screen. Yeah.
Yes, we can see.
Yeah, number 29, mechanics, yeah? So the question is, a particle moves such that its displacement from the origin at any time t is given by r is equals to 4t squared I plus 3tj minus 7k meters, yeah? So they have told us to find the speed of the particle at time equals to 4 seconds. Yeah, so when we are finding speed, we all know that speed is what? Is the magnitude of what? Of velocity. So we first have to what? Find velocity. And how we are going to find velocity is by differentiating the what? The displacement. So that's why I have part I'm saying that what? That I'm going to differentiate the displacement. Then I'll have, when I differentiate 40 squared, I'm going to have 8ti. Then when I differentiate 3t, I'm going to have 3j. Then when I differentiate a constant, that's 7, yeah? I'll have a 0. So that's why I have my velocity now as 8ti plus 3j meters per second. But remember they told me to find the what? The speed of the particle at t is equals to, in my velocity, I'm going to what? Substitute with a 4. So I have 8 times 4i plus 3j because the j does not have a t. Yeah, so my velocity is now going to be 32i plus 3j meters per second. Then I said speed is the magnitude of velocity, which is why I have root of 32 squared plus 3 squared. Then I have my speed as 32.140 3 meters per second. That is for part A. Then for part B, they say that find the acceleration of the particle at any time t. And for acceleration there, you now differentiate the what? The velocity, which is what I've done there. Then when I differentiate 8t, I'm going to remain with 8i. Then my 3j, it's like a constant, so it's going to be a what? A 0. Yeah, so that was number 29. Are there any questions?
Okay, you have in the chat, Sula says, pardon.
From where? The whole thing over.
Simply said pardon, so, but there are also 2 hands up. The one is yours, the other is Chris. Chris, can you say something?
Beno, please, can a little bit fast? I've got you. If possible, please pardon the word. Please and please.
Okay, now part A. They've told us that, okay, the question was saying a particle moves such that its displacement from the origin at any time t is given by r is equals to 4t squared I plus 3tj minus 7k meters. So now they are requesting us to find part A, the speed of the particle at time is equals to 4 seconds. But we know that speed is equals to the magnitude of what? Of velocity. And since we have been given displacement in our question, which is our r is equals to 40 squared, which is this one here. That one, that r is equals to 40 squared I plus 3t j minus 7k. So now we're going to what? Get velocity from what? From differentiating the displacement. So which is why I was differentiating there here in part what? In part A. So I differentiate the displacement. So when I'm differentiating, I'm going to have, when I differentiate 40 squared, I'm going to have 8t I plus 3, and I differentiate the 3tj, I'm going to have what? 3j. You guys learned differentiation. Then also when I differentiate the 7k, it does not have a t, so it's a constant. When I differentiate a constant, I'm going to what? Get a 0, yeah? So that's why I didn't have the k part of it. I only have my velocity now as 3ti plus 3j. Yes, meters per second. But it told me to find, the what? The speed of the particle at t is equals to 4. So in my velocity, where I have my t, yeah, I'm going to substitute with the what? With the 4, because they say that t is equals to 4. So that's why I have velocity here at t is equals to 4 seconds. I'm going to have 8 times 4, but I plus what? Plus 3j, because my j doesn't have a what? A t. So my velocity is now going to be 32i plus 3j meters per second. So now that is how I'm going to get my speed. Now that I have velocity, now I'm going to get the magnitude of what? Of the velocity, because that is how I'll find the what? The speed. So I get the magnitude, then yeah, I have my speed as 32.1403 meters per second. Yeah, then now for what? For my acceleration. Acceleration now, I'm going to what? I'm going to now differentiate the what? The velocity, yeah? Yes, because, yeah. So I'm going to, when I differentiate the 8ti, I'm going to remain with what? With 8i meters per second. Yeah, so you guys, if you are to notice that, okay, these things, Okay, yeah, that is how I what? That is how I hope everyone has understood.
Thank you very much, Beno. I just want, there's a question here that I've seen from Patience. Does it mean that when I'm given velocity and asked to get displacement, I integrate? Could you give her your mind? Beno, are you there?
Yes. Okay, now, like this.
Did you hear the question?
Yes, you say that, Patience said that now when I've been given velocity and I'm told to find displacement, I integrate. Yeah. So it's like from, so I have displacement, yeah? And I want to get velocity. Then I also want to get what? Acceleration, yeah? So from the displacement to go to velocity, I differentiate the displacement to get velocity. Now when I have velocity, I'm going to what? I'm going to differentiate the velocity to get acceleration. But now, you know that integration is reverse of differentiation. Yeah, integration is the reverse process of differentiation. So now let me say, I'm going to start from acceleration. If I've been given the acceleration here, yeah, and I want to get velocity, I'll integrate my acceleration to get velocity, yeah? And then when I've been given the velocity and I want to get displacement, I'll still integrate the velocity in order to get the what? The displacement. Yeah, hope you understand.
Okay, thank you very much. Please take note that this is when the displacement and the velocity and the acceleration are varying with the time. Otherwise, sometimes if you are told that the velocity is constant, etc., you should now, the differentiation will work, because if it is constant, the acceleration is 0. But take note that here, where she's enjoying, she's having the displacement and the velocity. They are given in terms of t, varying with the time. And then I just want to caution that the symbols. Then when I look at your work, sometimes I see the I as a vector. The vector symbol is there. In some other cases, I don't see that vector symbol. Please let's be consistent with the vector symbol.
Okay,
these are vectors, and be consistent. At all times, let us have the symbol and the vector symbol very clear. Then there are messages that I've not seen. I think that is people are doing the needful, and they are thanking you for the presentation.
You're welcome.
Someone is talking, this is who? Sula talking. Sula says she's comfortable now. There was someone who was talking about the symbol there. I've also seen someone who is asking something to do with the symbol. Please let the symbol be there. Okay, thank you very much. I think we should be working to close. But thank you for that. We are going to have those very last questions. I saw Mukalazi. Mukalazi, what question did you say you had in paper 1?
Analysis. I think we haven't done it.
Yeah. Let's have Mukalazi because he has really been there waiting for a chance. Okay, Mukalazi.
Thank you. So I'll be doing number 12 of analysis. I hope you can all see my screen.
Yes, please. You can see the screen.
Yeah. So the question was, given that y is is exponential tan arc of x. Show that 1 plus x squared times the second derivative of y plus 2x minus 1 times dy dx equal to 0. So the first step is, of course, we have the initial statement that y is equal to e raised to the power of tan arc of x. So to do away with the e and to have just tan arc of x, we can introduce ln on both sides, such that when we take the ln of y on the left, it gives us tan arc of x on the right. Since ln is the same as log to base e, so it's the same as tan arc of x times log e to base e, which is 1. So it's just tan arc of x. And then to do away with the tan arc, because we can't differentiate when we have a tan arc, we take tan on both sides. And so this statement here that ln y is equal to tan arc of x means that tan of ln y is equal to x. So we're labeling that equation star, and then we can differentiate on both sides. So we differentiate on both sides with respect to x. We need to know that the derivatives of all these functions here, of tan, ln, and of y. So when we differentiate the left-hand side with respect to x, we have to keep the chain rule in mind. So when you differentiate tan of, if this was x, we'd get x squared x. Then this isn't x. So we have to differentiate what this angle is with respect to x. So you differentiate ln y with respect to x. When you differentiate ln y, you get 1 out of y, and then times the derivative of y, which is dy dx. So when you differentiate this whole left-hand side tan ln y, you get x squared ln y times 1 out of y, which is the same as divide by y, this step there. And then when you differentiate the right-hand side, you get 1. So you can make, yeah. So you can make the left-hand side, make dy dx a subject on the left-hand side, such that you have this equation here, that y out of dy dx equal to y out of x squared ln y, when you take all those things to the right. And then because in what they expect us to show, we see a second derivative, we know that we have to differentiate again with respect to x. So this time, this differentiating the left-hand side gives us the second derivative of y. And then differentiating the right-hand side, we'll have to use quotient rule because these are two different functions. And we're differentiating, we shouldn't forget we're differentiating with respect to x. So differentiating this as a quotient with respect to x, we would use, if the quotient is u over v, we'd use v du dx minus u dv dx divided by v squared. So our v is x squared ln y. Our v is x squared ln y, and our u is y. So v du dx would be x squared ln y times the derivative of y, which is dy dx, minus y, this y here, times the derivative of x squared ln y. And when you differentiate x squared ln y, you have to know now that you're going to use the chain rule. When you differentiate, when you're differentiating, you use the very first rule we learned when we're differentiating, that reduce the power by 1 multiplied by the new power. So reduce the power of sec by 1, so it becomes just sec, and then the power 2 becomes a new power. So 2 sec ln y times the derivative of sec ln y, which is sec ln y times tan ln y, then times the derivative of ln y, and the derivative of ln y is 1 out of y, that's why I'm dividing by y, then times dy dx, because all this differentiation is with respect to x. So I think that's where the major gist of the question is, this differentiation here. So you have to make sure that you know your chain rule thoroughly. And then all this, of course, divided by sec, the denominator squared, which is sec to the power 4 ln y. And then you can, when you simplify that, if you divide all through, because you see that sec sec ln y squared is common. If you divide it in the numerator and denominator, you're left with just x squared ln y in the denominator, and then you can factor out dy dx in the numerator, and you'll be left with 1 minus 2 tan ln y, which is right there. And then multiplying sec squared ln y on both sides, you have sec squared ln y times del e2y dx squared, and then you rearrange it such that it's close to our original, what we wanted to prove. So you take dy dx to the left-hand side, and then from equation star, this equation right here, from equation star, we have that tan of ln y is equal to x. And we have sec squared ln y. And in our proof, we have 1 plus x squared. So there's no room in what we are required to show for any trig functions, any logarithmic functions. So we'll plan to use this equation star to substitute into this equation to get what we're required to prove. So you realize that from trig identities, sec squared can be written as 1 plus tan squared of the very angle. So you have 1 plus tan squared ln y multiplied by del e2y dx squared plus 2 times tan ln y minus 1 all multiplied by dy dx equal to 0. And then from equation star, you realize that tan, this is the same as tan of ln y squared, and we have tan of ln y as x. So this can be written as 1 plus x squared d2y dx squared. And then we have tan ln y here, which can be written as x from equation star. So using those substitutions, then we get what we're required to show that 1 plus x squared multiplied by the second derivative of y plus 2x minus 1 multiplied by dy dx is equal to 0. Yeah, was that okay? That's
Thank you so much. Thank you so much, Jonathan. I love the passion that you have for these things, and you're connecting them very well. Thank you, Jonathan. I also want to thank the previous presenters. Jonathan's approach is still on the screen. If you want to further look at it, please, you can take a screenshot. However, I would wish to Jonathan also to look at this way. As we conclude, we are concluding. I thank those who are still on. We are just a minute away to our closing, and we would wish we stay together to those last bits. Okay, just for another direction, we have been given y as e to the power the tan inverse of x. We want it to be 1 plus x squared, the second derivative, that is multiplied by the second derivative, plus 2x minus 1 dy dx. I want to give you a would-be different direction. Of course, we all agree that when given e to power say x, by rules, the derivative is a derivative of the power with respect to x is a, and you rewrite that exponent. I would want us to take that direction, and we see how it will behave. So if I pick up my statement I've been given, y is the exponent of arctan of x, the y dx immediately would be the derivative of that power, the derivative of the tan inverse of x multiplied by e power tan x. I believe that is clear from what I've just explained. Drop the derivative of the power, write the exponent. So I want to come aside here and differentiate that exponent in steps. Suppose I let u be that tan inverse of x. It means tan u in reverse The angle was u, which was equal to x. The tangent of u was x. Derivative of tan is sec squared u. Derivative of the angle u with respect to x would give us du by dx. When you differentiate x with respect to x, you get 1. You would clearly see that du by dx is the same as 1 out of sec squared u. And by identities of trigonometry sec squared u, I can write it as 1 plus tan squared u, meaning this is 1 out of 1 plus, but we know that that tan u is x from this point. So this becomes x squared. And this is d by dx of u. That u was the tan inverse of x, if someone recalls. So this statement here now settles to dy by dx. dy by dx becomes 1 out of 1 plus x squared multiplied by, I don't want now to keep this exponent because in the proof I want there is no exponent. So e power tan x, I want to write it as y, so that I compress this proof. So when I cross multiply, this statement can be put down as 1 plus x squared. I can keep this as dy dx equal to y at that point. Is that fine? Is that fine so far? So those are the two different ways. Mukalazi, was it John Mukalazi was presenting?
Jonathan.
Jonathan, yes, Jonathan. As we conclude, we share your approach as well. I see in the chat someone.
I screen share.
Someone wants to see this one. They want yours as well. Let me first show this. People want to screenshot the two. If that is done, lastly, this was the last bit. So Jonathan, in that point also, share yours. It's good for people to have the variety of directions. It helps them when practicing. I want to thank you so much for coming to attend this HELP National Mathematics Seminar. This has been one of the first sessions we have had this holiday, and we hope to set up, God willing, one more. If not, we would wish you a nice session for the next term. If we don't come back again to meet as the Mathematics National Group, at HELP, we'll always stick with you till you do your national exams. We are happy to have you from the different schools. It's sharing, it's the purpose here. I didn't get to know the school Johnny Mukalas is attached to, Jonathan. And thank you, presenters and participants, for representing your schools. Jonathan, what was your school?
Oh, teacher, I'm in King's College, Budo.
King's College, Budo. Thank you. King's College, Budo. All right, over to you, my chairman, Mr. Kajimu. I would beg you take the honor to close this session.
Thank you very much, Teacher Lawrence. Thank you very much for that guidance. Thank you very much for taking us through, and also for guiding us here and there whenever we wanted. May I request, before we have the closing prayer, to have a word closing from Teacher Emma, and then the closing word, the closing remark, Teacher Emma.
Okay, thank you, Teacher Kajimu. I hope I'm clear.
You are clear.
Okay, I would like to also add my voice to thanking the participants who have taken part in this seminar.
Could we have lost Teacher Emma? Are you there? Okay, sorry about that. I think it could be network. We can't hear anything. Okay. Thank you very much, Teacher Emma, although we can't hear you. May I request you to have a word from Teacher John Bakayana as we close? Yes, oh, sorry. Okay, you can, good.
Okay, thank you so much, Teacher Lawrence. Thank you so much, Teacher Emma. Thank you so much, Mr. Dung, for the opportunity. And then Teacher Kajimu for this great opportunity also. Thank you so much, learners. I've really appreciated and I still appreciate. And I know that more of the same kind will come out. It has been so much educative, and I believe we teachers have learned and the learners have learned the most. So I pray that in the next session, we can encourage many of our friends to join us. Thank you so much. May God bless you.
Thank you, Teacher John Bakayana. I want also to add my voice to thank the presenters. Please, thank you very much. And also to thank the teachers. We are blessed to have all those teachers guiding us all the time. And they are ready. And we want to thank Mr. Dungu for this setup and for guiding us all the time. And also Mr. Kaziba, who has not been with us. He has been in another room guiding the O-level students. We want to thank you so much for this opportunity. Mr. Dunga, I don't know whether you are here. You could say 1 or 2 words as we close. And Mr. Dunga, are you there? Okay, otherwise I want to thank you. May I have a volunteer who is going to lead us in prayer? But before, may I see a volunteer leading us in a closing prayer?
Teacher Kajimu, sorry, I dropped my network, got issues, but I think I was done.
No, you are going to say something as before the prayer. Please go ahead and continue with those words. We want them, Mr. Teacher Emma. Chris, you are going to lead in prayer after Teacher Emma. Please, Teacher Emma.
No, Mr. Kajimu, we can continue. I was done.
Okay.
I think you got all.
Otherwise, we thank you very much for always guiding us here. And we want to thank all the teachers, Teacher Lawrence, Teacher John, Teacher Emma, Mr. Dungu, and Mr. Kaziba. Okay, Chris, can you lead us in a closing prayer?
Mr. Dungu is back.
Before you close.
Oh, Mr. Dungu is back. Thank you, Mr. Dungu. Yes, please.
Yes, I could not unmute myself. Thank you for unmuting me. I would like to thank the teachers for guiding us through this session. I would like to thank the students who have joined in. We continue to support you all the way until when you sit your exams. If there are any senior fives who joined in today, we will also continue to support you all through your A-level section. We will be providing the recording in your WhatsApp groups. And for those who are not yet on our WhatsApp groups, you need to join in the WhatsApp group because that's where all the information comes in from. And we are working towards having the A-level mathematics seminar organized across schools, either end of June or early July, whichever the best day will be, so that we bring all the schools. And we work towards having all the Ugandan schools joining on one platform, on one Zoom, so that we listen to each other and we prepare ourselves for the final exams together. So we thank you for joining in, and please, let's work together going forward. I hope next weekend we might have chance, but there are also other subjects that are waiting. If we don't come back for mathematics, we'll see you in other subjects. Thank you.
Thank you very much, Mr. Dungu, for those remarks. Now may I invite Chris Peters to close with a prayer. Chris Peters, please unmute.
And let's pray in the name of the Father and the Son of the Holy Spirit.
Amen.
Good Lord, thank you for this. Good Lord, we'd like to thank you for our teachers. We'd like to thank you for this platform and this wonderful invention. Good Lord, I would like to pray for the gift of the Holy Spirit of wisdom, such that we can all pass well. Our examinations, may what we do, and other. Bless our teachers, bless each and everyone who is involved in this invasion, such that, Lord, we may move on smoothly. Father, we pray for your guidance, we pray for your protection throughout this week and throughout this short holiday, such that we can go back to school when in good shape. In the mighty name of Jesus Christ, I have prayed. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen.
Thank you.
Thank you very much, Chris Peters. I want to wish everybody a nice weekend. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Bye.